So here's a next example of an approximation of an optimization problem. So keep handy those 7 steps that we wrote down. Just gonna make sure that we hit all 7 of them as we go. So if y is equal to 2x minus 8, what is the minimum value of the product xy? So question 1, what quantity am I trying to optimize? The quantity I'm trying to optimize is the product of the 2 variables x and y. And specifically, I want to minimize that product. So step 2 is to write a function that relates those 2 quantities. Well, a function for that product. So I'm going to write p equals xy, but notice the rule is can't really optimize until I can change that into an equation in one variable. So I'm going to change my p function. Instead of being x times y, I'm going to notice that y is equal to 2x minus 8, so I'm going to replace y with 2x minus 8, and here's my new function. The product, the thing that I'm trying to minimize, is equal to 2x squared minus 8x. Now I know I'm going to need the derivative of that quantity because I need the critical points for that quantity, in this case the critical points for the product. So that derivative is 4x minus 8. 4x minus 8, again, like that last example, is linear. So it's never undefined. I won't have to worry about critical points coming from f prime, or in this case p prime, being undefined. But I do have one critical point that arises from p prime equaling 0, and that's at x equals 2. Now I'm going to make my table of values. Ooh, notice this, we better fix this up. I was asked at the beginning to find the minimum value of the product. So that's not correct to have said that I wanted to maximize the product. I want to minimize. Hope you'll fix that in your notes if you're writing down notes. Okay, and so something to notice on this problem, I've been asked to minimize the value of x times y. X times y, especially if I write it like this, I can see that's just a parabolic function. There's no endpoints implied in the problem, and there's no endpoints implied by the actual function. So when I make my list of values, I only have one value because I only had one critical point. So that's a possibility. So we're going to try now to see if letting x equals 2 is actually a minimum, or if somebody was trying to trick us. So when I let x equals 2, I'm going to evaluate p of x at x equals 2. That's going to be 2 times 2 squared is 4, minus 8 times 2 is 16. I get 8 minus 16, which is equal to negative 8. So is that one of the answer choices? Yes, that is. That's a good sign. I do want to perform at least one more test. So there's a couple ways you could think about this. I want to make 100% certain that this value I got, this negative 8, is actually the minimum, and it's not instead the case that this function has no minimum, and that maybe at x equals 2 there was a relative maximum. So you can try plugging in any other x value. If I plug in 0 for x, that's easy. Doesn't matter what y is. I plug in 0 for x, I would get a product of 0, which would be bigger. And I was looking for the minimum. So it turns out that this very smallest I can get for x times y, if y is equal to 2x minus 8, is negative 8. There's another way you could think about it too. This function, p, when I write it as a function of one variable, is quadratic. That means if I graph it, it has to be a parabola. I notice the leading coefficient is positive. That means that the parabola must open up. That means that the vertex of the parabola must be a minimum of the parabola. So all of those together confirm for me that I have a minimum value of negative 8 when x equals 2. I'm just going to point out that notice that 2 is one of the answer choices. It's because they're trying to get you to do all the right math and come up with x equals 2, but then forget that the minimum value is actually the result of plugging in this x value to the function you're trying to optimize. So minimum value, negative 8.